Okay, so again, we're skipping problem number 4. Make sure that you draw your hill, draw the line below, put your notch in the middle, draw in your lower z-score and your upper z-score with lines straight up and shade between them. Then you're going to do second bars, normal CDF, of your lower z-score, comma your upper z-score, to get the probability. Don't forget that you need, if you have a fancy TI calculator, it gives you other options, like the mu and the sigma. The mean, the mu is 0. The sigma, standard deviation, is 1. Okay, so back to today. Here's today. So today we're going to finish up 6.1 and 6.2. We have just a little extra part of 6.2 we have to finish up, and then we'll take a break. When we come back from break, right away after back from break, I'll show you my first magic trick, and then we'll do 6.3 central limit term. It's probably as far as we'll get through today. Tuesday, we'll have Connect Math 6.1 that's today. Oh, no, tomorrow. Connect Math 6.1 is due tomorrow. And then Thursday, 6.2 is due. Okay, everybody look up. Connect Math 6.2, you need to make sure that you use 2 decimal places for the z-scores, and you use 4 decimal places for the areas, for the probabilities. If you don't do that, it's going to, if you round your z-scores to 3 decimal places and put it into normal CDF, and put your answer in, it'll mark it wrong. So you need to round to 2 decimal places. Everybody on board? So that's for 6.2 and 6.3. Also note that those are due, if you decide to take the exam early on Thursday, then it will mark you, then these homeworks will not be due yet. So you want to either maybe try to do them a little bit earlier, ideally Wednesday, if you can. At least the first one. If you don't get to the second one, 6.3 until after, then as long as you kind of know how to do the problems, I guess that's okay. I don't know. It's up to you. Just make sure you know how to do. Make sure you know how to do the practice exam. I'd say that's the most important thing, right? You can take exam 2 either Thursday or Monday at either 2 o'clock, 5 o'clock, or 7:30. Your choice. Any one of those times is fine. If you want to take it on Monday, or even if you want to take it Thursday later, there will be a review session next door. Andrew's going to be in there working with you folks at 2 o'clock and at 5 o'clock. Okay. This is that Connect math problem I was telling you about. One of them. There's several of them throughout here, but for example, this is 6.2 using 2 decimals for z-scores and 4 for area. So it says round your z-value calculation to 2 decimal places. So here, it's negative 0.55. If you put negative 0.548 and put that into your normal CDF, you're going to get the wrong answer. It'll be off a little bit, just enough to mark it wrong, and for you to bang your head against the wall several times. Try to do this for hours and hours. Good. So don't do that. That would be not the best choice. This actually doesn't affect you folks. Leave that alone. Okay, good. So again, the exam, you can take it either Thursday or on Monday. You can take it either 2 o'clock, 5 o'clock, or 7:30. There will be 2 parts. The first part of the exam will be just using a basic calculator, like this. Right? So it just has addition, subtraction, multiplication, division, some very, very basic square roots, some super basic stuff. I got this one from the dollar store. Who needs one of these? Who does not have one of these? Put your hands up high. 1, 2, 3, 4, 5, 6. You want yes or no? 6, 7, 8, 9, 10, 11. Okay, I'll make sure I have 11 of them. Change this question. So you 11 can get one. If anybody else wants one, you didn't raise your hand, so you will not get one. So I'll have these available for, actually, depends on which day. So who's taking it on, right, oh dear. I guess we'll see. Hopefully things will work out and everybody won't be taking it Hopefully everyone doesn't take it Monday night at 7:30, the last possible time, and I don't have enough calculators, but it should work out. Okay, I'll bring extras. The second part is going to be, you need a TI 83, 84 calculator. So who here needs a TI 83 or 84 calculator to borrow for the exam? 1, 2, that's it? Everybody else has a TI 83 or 84? 3, 4? Okay, everybody else has one? Cannot use your phone, obviously can't use a computer, stuff like that. Okay, that should work. It covers chapters 3, 5, and 6. It does not cover 6.4. And then also you're allowed 1/2 page, one-sided of handwritten notes, handwritten by you. Again, you can use the top half, can have your exam 1 notes on it, and the bottom half can have your exam 2 notes on it. That's fine, because I can tell, as I look through people's notes, I can tell exam 1 material from exam 2 material. So that's a piece of cake. No worries. Okay. So as you remember, the binomial distribution is my favorite distribution because the mean and standard deviation are the easiest in the world to compute. The mean is NP, variance is MPQ, standard deviation is the square root of MPQ. Piece of cake, super, super straightforward. Who needs just another 30 seconds to finish up problem 1? Everyone has problem 1 done? Really? All right, good job. Okay, we'll go through problem number 1. All right, so find the mean and standard deviation. My mean is NP. 14 times 0.25, 3.5. My variance, NPQ. So it's going to be 3.5. My NP is this part, and it's multiplied by my Q, 0.75. Because remember, P and Q have to add up to 1 or 100%. So if my P is 0.25, my little Q is 0.75. I don't remember what I got for this. Anybody? 2.625. 2.625. Okay, great. So you need to either use 2.6 or 2.625, either one. My standard deviation is the square root of NPQ. So that's the square root of 2.625. And you get 1.62 or 1.6 if you round it to 1 decimal place. So either one of those is fine. I don't care. It's all good. All right. Next. There's problem 2. Which 4 can be used interchangeably? Was anybody unsure about this? Okay, we'll take a look. Everybody read this. Try to make sure you check your answers and can answer it. Area under the curve is same thing as probability. Same thing as percent of population in that range. So if you look at the picture, you'll see between a negative z-score of -1 and +1, there's 68% of my population. So the area under the curve is 68%. It's also the probability that a z-score is between 0 and 1, or sorry, -1 and +1. And it's also the percent of population that lies between those two. Yeah?
It's probably a stupid question, but it says 4 terms on
Right.
here.
Yep. So the first 3, you folks feel pretty confident about the first 3 at least? Okay. Okay. Now, let's knock out the first 3 then. Somebody give me one. Probability. What's another one? Areas. What's another one? Percent of population. Great. So what other things also are, what's up with probability percent of population areas? What do you know about them?
Z-score.
Okay, so what do you know about them? What do you know about, everyone knows a couple of things about probability. What's one thing you know about probabilities? It's less than what? It's between what and between 0 and 1. It's between 0 and 1. So which of these things are also between, what's something else you know? Go on.
Oh, I was just going to guess that maybe they were all statistics.
Well, that could be true too. But yeah, let's take a look. But yeah, so let's look at probabilities may or may not be. But, okay, let's look at the things, the laws of probability. So there's two things we know about them. One is, the first law of statistics is that they need to be between 0 and 1. Everybody on board with that? What's my second law of probability was that,
They don't want to add it to 1.
yeah, if you add up all the probabilities in the sample space, it has to equal 1. Which of these things follow that their values are between 0 and 1? Will all x values be between 0 and 1? No, absolutely not. Will all means be between 0 and 1? Will the average be always between 0? No. Will every statistic be between 0 and 1? Oh, I see what you're saying. I see what you're saying, yeah. Will all z-scores between 0 and 1? Will all relative frequencies be between 0 and 1? Yes. The relative frequencies are also the percent of population that's in that class. Does anyone remember that part?
Yes.
So that's also. Now, that one is a little less directly applicable, but it's the same concept. Does that make sense? So really, these other three are really identical. This one is borderline identical. It's very similar. You following me? So on the exam, I might only ask you for 3 and not include that one. But that would only be an extra credit problem. It wouldn't be a straight up regular problem. Okay. I'm giving you guys so many kids here. All right. How do you use a calculator to find the area under the curve? Normal CDF. You do second bars down to normal CDF. And then you put in the lower z-score, comma, the right z-score. The lower z-score, comma, the upper z-score, right? So as you've shaded your area, the left z-score here, the lower one, this is the upper one. If you have a fancy calculator, you might have to put in a mean of 0 and standard deviation of 1. I did not do that. Hold on. All right, so your quiz problem 3B. Let's do 3B first. Has everyone had a chance to do this one? Great. I'm going to draw a picture. Oops. Maybe not. Okay. Draw a picture. Draw your hill, put your line below it, and then put a little tiny notch right in the middle. That's where your mean is 0. Where where your mean is, where your z-score is 0. And then my z-scores are 0.31 and 1.68. So what do we know about z-scores? A z-score represents what?
The number of standard deviation.
Above or below the mean.
Yep. Number of standard deviations value is above or below the mean. So if I'm above the mean, my z-score should be positive. If I'm below the mean, my z-score should be negative. Our z-scores here are 0.31 and 1.68. Should they be on the left side or the right side? On the right side. So they should be, I don't really care where, but they should be somewhere on the right side. You would have to be that exact about that part, just as long as at least you get where they are relative to each other and to the mean, to the middle. And you're going to shade between there. Now you're going to do normal CDF. Right, I want to find the percent of population. So again, remember, percent of population is the same thing as the area under the curve. It's the same thing as the probability. They're all the same. 0.31, comma, 1.68, and you got 3318? Okay, good. So this is exactly what you need to do. This is the bare minimum you need to have to get full credit. I need a picture. I need the notch in the middle. I need your 2 z-scores shaded between them. Write out, this is showing your work. Showing your work is writing out normal CDF of blank, comma, blank. And then your answer.
And then always 4 decimals, right?
Yeah. So 4 decimal places for the areas. It's not my convention. It's what the z-tables have sort of defined everything as. So the z-tables use 2 decimal places for the z-scores and 4 for the areas. So that's what we're going to go with. Okay. Well, what if you only have 1 z-score and you want the area to the left of it or to the right of it? If I do that, then basically I'm saying, here's my first z-score right here, right? Whatever it is, negative 0.6, whatever. But what's my z-score way out here?
Negative infinity.
Negative infinity. So make sure you put that in there when you draw your picture. Put this way out here on the very, very end, negative infinity. Good. I think I'll let you guys use different numbers instead, but let's use negative infinity. I think infinity, that just makes things clearer. Because off to the right, what's the number way, way, way out here? Positive infinity. So again, go ahead and put them in there and mark it in there, positive infinity. So then it's easier what you're putting in, normal CDF. And instead of negative infinity or positive infinity, just use some, since I don't have infinity on my calculator, I'm just going to use some large number. Right? Someone suggested 600. I like 600 for a couple of reasons. One, it's large. But two, even if, before I used to use 999 with people, and soon to be, 90% of students would be great with that. But 10% of them, like just a few each class, would put in 0.99 instead of 999. And that is totally wrong, right? Like 1 is not large. 0.99 is not, that's 1. So 600 I think is kind of better, because I think people might, if you actually put in 6.00, that's still large enough. That's kind of okay. So I kind of like 600 for that reason. But whatever, put infinity out here. So let's take a look at quiz problem 3, the first one. So has everyone drawn their hill? Put your mark in the middle. Where's 0.75? Somewhere here on the right, I don't care where. And do I want below it or above it? Yeah, so here's the thing. Here's my little, draw your little fish. Remember, the little guy is easier to catch. So he's already eaten. So 0.75 is smaller. Z is bigger. The bigger one's harder to catch. So Z is bigger than this. It's bigger than 0.75. So you want this area out here. So that means I'm going to end way out here at positive infinity. If you did less than, then just take your answer and subtract from 1, because you know that these two halves have to equal 1 or 100%. And you should get the answer that way. But I'm going to do normal CDF. 0.75. What's my right z-score? Yeah, infinity. So 100. I'll do 600 just to be safe. And what did you get?
I did 368. I got
0.22. Anybody else? 66? Okay, great. Perfect. All right. This is as a side note, if I did normal CDF of 0.75, 600, and I did normal CDF of negative 600 to 0.75, and added them up, what should I get? 1. Should get 100%. Right, those two parts. And if I had normal CDF of negative infinity to positive infinity, what do I get? From negative infinity to positive infinity, if I did normal CDF of negative infinity to positive infinity, I would get 1, 100%. I get everything. Make sure we're kind of understanding that how this all kind of works. All right, so quiz 4 we're skipping until tomorrow. So don't do that. Okay, applications. Right, applications are just one more step we're adding to what we've just been doing. All we're doing is taking our values, our actual real-life values that we care about, converting each of them to a z-score, and then moving on with what we've been doing. And then it's just put your z-scores into your drawing picture, put in your z-scores, shade, normal CDF. Just one extra step in front, convert your every x value to a z-score. How do you do that? You take your value, subtract the mean, divide by standard deviation. Because this tells you how many standard deviations it is away from the mean. If it's below the mean, it better be negative. Above the mean, it should be positive. Here are those steps if you did not fill them into your notes. Those go into your notes. So first, convert your data values. Oh, I might not have done that with you folks, huh? Everyone bust out your chapter 6 notes. It is at the top where it says 6.2, the very top of 6.2, which is on the first, second, fourth page.
Fourth page.
Fourth page, top of the fourth page, 6.2. The very top, there's some blanks I did not have you folks fill in, so fill them in now. 6.2 notes. Okay, good. So convert your data values to z-scores. Draw a picture. Use Normalcdf to find the areas between the z-scores. All right. Here it is visually. You take your x value, you convert it to a z-score. They're both right here. And then you're going to use Normalcdf to figure out what the area is. Probability that your z-score is between what you want, the numbers you want. Here's an example. Liters of blood. So here, average of 5.2. That is my mu. Normal distributed, standard deviation of 0.03. That's my S. And I want to find the percentage of people who have less than 5.4 liters. That's what I'm trying to find. So this is my x value. So first I need to find my z-score. So I'll take my x value, 5.4. I'll subtract my mean, 5.2. And I'll divide by my standard deviation, 0.3. If I do that, I'll get 0.62. Now that's my first step. Once I have that, then I draw a picture. But am I not? 0.67, is that on the left or the right? On the right, 0.67. Draw a line up. Do I want less than it or greater than it? Less than, that's on the left side, over here. So then I'm going to do Normalcdf. Or maybe I'll do it below. Okay, when there's like one group talking, that's one thing, but when there's 3 groups talking, that's just a lot harder. Normalcdf, whisper of negative infinity. Negative infinity way out here. So that's going to be negative 600, comma 0.67. Right, and then you get whatever you get. All right, so this is your problem. Find your z-score for 200. Find your z-score for 220. Figure out what your average is. What's my average? So 1.8 ounces, is that my average? No, that's just the kind of chocolate bar we're talking about. A 1.8 ounce chocolate bar. That has nothing to do with the numbers you need. That's just telling you what kind of chocolate bar it is. It's that size of chocolate bar. The average is what? Average is 225. Find the word is. Sigma is 10. All right, I'm going to give folks just another 2 minutes to do A, B, and D. If you get to do C too, that's great. If you can't figure it out, that's okay. But do A, B, and D first.